using trig ratios is one of those applied parts of our maths. So we learn our basic trig ratios, sine, cos, and tan, and we practice on nice, simple triangles, and then we move into actually working with applied questions where we have all sorts of things going on, and we've got to find those triangles, pull them out, and then use our sine, cos, and tan. So this lesson is going to recap a little bit on our right angle triangle and our sine, cos, and tan, and then we're going to look at some past paper questions that actually use those skills within questions. So starting out, when we're working with sine, cos, and tan in their most basic form, we're working with that all-important right angle triangle. Okay, when you've got a right angle triangle, with that great big fat 90 degrees sitting there, then you've got two things that you always want to keep in mind. First one is Pythagoras. So h squared equals a squared plus b squared. So your hypotenuse squared equals the sum of the squares of the other two sides. Okay, then the other thing that you're always keeping in the back of your mind as soon as you see that right angle triangle is your trig ratios, which is your sine, cos, and tan. So overall, SOHCAHTOA, that very friendly phrase that's going to help you remember who goes where. So in order to use SOHCAHTOA, we need to know what each of those are. Okay, so H looks familiar because he's in Pythagoras. So H is a very important one. It's the one facing the right angle, and H is your hypotenuse. We always use H for hypotenuse, and then it's nice and standard across everything. So in SOHCAHTOA, we have our H. Who's our O and an A? Well, O stands for opposite and A stands for adjacent. But we can't label those unless we actually label an angle. Okay, so let's say we're working with this angle here. We'll call him theta for fun. Okay, for this theta, adjacent, if you live adjacent to somebody else, you live next door to them. So the side that is the adjacent side is the side that's next door to the angle. It's the one that helps make the angle. Okay, so hypotenuse and adjacent will help make theta. So here's adjacent, and then opposite, if you live opposite somebody, they're on the other side of the road. So in this case, they're on the other side of the triangle. So here is our opposite for theta. The thing with these angles is they get a bit funky because they like to be individuals. Okay, so if we had an angle here, let's say this is angle X. Well, now we said adjacent is the one that's next to. So this is now adjacent. And opposite on the other side of the triangle would be opposite. So which side is opposite and which side is adjacent depends on which angle we're looking at. Hypotenuse always stays the same. He's always opposite the right angle. Okay, so we have our trig ratios, sine, cos, tan. We have SOHCAHTOA. We can figure out who's adjacent and who's opposite. What does SOHCAHTOA mean? Just double checking before we move on any further with that. So a lot of people write it like this. Okay, I like to write it like this, because this is even more of a reminder. Sine theta equals opposite over hypotenuse. Cos theta equals adjacent over hypotenuse. And tan theta equals opposite over adjacent. So tan is the odd one out. He doesn't involve the hypotenuse. Okay, so SOHCAHTOA helps us remember which one is which size we're going to need to use when we're working with a particular angle. So to get more into detail on this one, then you can go visit the other lesson on actually using SOHCAHTOA. Now we're just going to do a quick recap with a few triangles to make sure we're all on the same page before we actually then go and use those ratios in questions. So let's get us some triangles. So you should see something familiar going on, all sorts of wonky shapes, but at the same time, all of these have a right angle in. Remember, as soon as we see that right angle, we are thinking Pythagoras and we're thinking SOHCAHTOA. What am I going to be using? Okay, so we have a variety of different options here, and we're going to work through all of them as a warm-up. So, triangle number one, in each of these triangles we're looking for x. So we look at our triangle, we say right angle, coolness. Two sides and an angle with an unknown angle, so we're working now with SOHCAHTOA. Which sides have we got? We've got opposite the right angle, so we've got H, and we've got next door, adjacent, we've got A. So if we're working with an A and H, let's put SOHCAHTOA up so that we can see it while we're doing this. Okay, who are we working with if we've got the A and the H? We are working with cos, because cos x is going to equal adjacent over hypotenuse. So now we know that cos x equals adjacent over hypotenuse. Okay, so cos x equals 3 over 12. So this is not going to simplify very nicely. So in order to get back to an x, remember we have to do the inverse, we have to do the opposite when we want to solve equations. So it's the same thing here. Instead of doing cos, we now need to take cos away, we do cos to the minus 1. So x equals cos to the minus 1 of 3 over root 12. We type this all in our calculators, exactly as it looks, equals, and we get a beautiful answer of 30 degrees. So we now know that the angle for x is 30 degrees. Looking at question 2, what have we got here? Here we know our angle, but we have a side that's missing. But we have that same relationship, right angle triangle, two sides, one angle. So we can work again. So now we look at it and we say, okay, we've got an angle. Which sides have we got? We don't have the hypotenuse here, but we do have the side that is next to the angle. So we have adjacent. And we have the side on the other side of the triangle. So we have the opposite. Which of our trig ratios works with an A and an O? Tan, because tan theta is opposite over adjacent. So here we would know that tan 37 equals opposite x over adjacent 4. Well, tan 37 we can put on our calculators and get a number. Okay, but it's going to be a bit of an ugly number. So we'll leave it till the very end to evaluate. So we get then what we're going to do, clear this fraction. Clear a fraction by multiplying. Multiply both sides by 4 to get rid of him. So x equals 4 tan 37. Now we can plug that into our calculator. 4 times tan 37, then close brackets as well. Okay, so x equals 3.01. So if this had centimeters on, for example, that would be 3.01 centimeters. Okay, 3 significant figures unless told otherwise. Next one. I'm hoping this is recap after you've done your lesson and you're happy with your SOHCAHTOA. Okay, so now we've got another triangle and we're looking at what have we got? What are we working with? Right angle, two sides, one angle, unknown side. Okay, so looking at the angle, what have we got? We've got the hypotenuse and we've got the opposite. So who works with O and H? It is sine. So now we know that sine 27 equals opposite 4 over hypotenuse x. So now we've got the same thing. We've got an x, we want to solve for it. Sine 27, that's a number, but we're going to leave him tucked up until the end. Okay, so x, we don't want him on the bottom, so we need to multiply both sides. So we have x sine 27 equals 4. Well, we don't want x times sine 27, so we're going to divide by sine 27. So we're going to get x equals 4 divided by sine 27. And again, you've got a fraction even on your calculator. So 4 divided by sine 27, you can plug it in. And then you're going to get x equals 8.81. So if this triangle's in meters, your answer would be 8.81 meters. So you're always checking the units that are given in the question for your answer. And one more for warm-up. Unknown angle again in this case, but we have the same thing. Right angle, 2 sides, 1 angle. Okay, so we look at our angle. We don't have the hypotenuse. We've got the opposite and the adjacent, which means we're working again with tan. So in this case, we would have tan x equals opposite 6 over adjacent 2.1. Okay, so tan x equals 6 over 2.1, which is a little bit ugly. So tan x equals 20 over 7. Now, we don't really want to turn this into a decimal. It's 2.857142857. I mean, it's long, it's ugly, and it's not as accurate if we round it off. So we'd rather work with it like that fraction. So we've got the tan x. We want to do the opposite of that, so we can get rid of that tan. So we need tan to the minus 1. Tan to the minus 1 of tan x gives us x. Tan to the minus 1 of 20 over 7 is much more interesting. That gives us x equals 70.7 degrees. Now this is an angle, so we want to give it to 1 decimal place. That's our standard rounding for angles. So you can see now how it works in terms of, we're looking at our triangle. First thing we see is a right angled. Then we're thinking of Pythagoras and SOHCAHTOA. When we have 2 sides and an angle, we're going to SOHCAHTOA. Okay, we're going to spot our interesting angle, and we want to label the sides so that we know which one's the ones we've got. We're using then SOHCAHTOA to figure out which calculation we're working with. So it's all very well and good when it's nice, neat triangles like this. What happens when we then take that into past paper questions and things get more interesting? Okay, so I have got a question just quickly come through on that last one of why it's 20 over 7. If you take 6 divided by 2.1, then your answer is 20 over 7. And we're using that in fraction form so that it is more accurate. Okay, so 6 divided by 2.1, 6 divided by 2.1 equals 20 over 7. Let us now get to some past paper questions. So we are starting with something that looks a little bit familiar. Okay, not too different from the questions that we've just been working on. 2 sides, angle, right angle triangle, calculate the value of x. So just because it's a past paper question doesn't make it any different. We use exactly the same approach. We're going to say, okay, here's my angle. So what have I got? Opposite my right angle, I've got my hypotenuse. Other side of the triangle, I've got my opposite. So we're working now from our SOHCAHTOA. We want O and H, so we're working with sine. So in this case, we would have sine of 53.2 equals opposite over hypotenuse. So x over 29. So very similar to what we've done. We want to get rid of that 29, so we multiply both sides by 29. So 29 sine 53.2 equals x. And then we can take our calculator, 29 times sine 53.2, close brackets. And x is going to equal 23.2. Here we've got a proper question. So we check our units. We see it's centimeters on our triangle. So x equals 23.2 centimeters, because those units are important. So we do get these nice, straightforward and simple questions, but we also get some more applied ones, a little bit more fun. Like this one. So R and T are points on a circle, center O, radius 5 centimeters. PR and PT are tangents to the circle, and POT is 78. A thin rope goes from P to R, round the major arc R to T, and then from T to P. Calculate the length of the rope. So we've got to go all the way up here, all the way round, and then all the way along. And what they're starting to do here is they are building in other things alongside our trig. But we've still got to get that, pull out the triangle where it's going to be useful. Okay, so if we just take off my blue bits there for now so we can see what's going on. One key information is a tangent meets a radius at right angles. See, now we're getting magic going. So if we draw this triangle out, not quite so badly as that, we have a 78, we have a right angle, and we have a 5, and we have this side PT, which we need to calculate, because in order to get the length of that rope, we need the length of that side. And what's really cool is that PT and PR are the same length. Now, if we think about it, we've got two sides and an angle, and we've got a right angle triangle. So here is our SOHCAHTOA within another question. Okay, so what have we got? Which sides have we got? Well, on the other side of the triangle from our 78, we've got our opposite, which is our PT. And then we've got the one next to him. We don't have a hypotenuse. So we've got opposite and adjacent. So if we consider SOHCAHTOA, opposite and adjacent belong to tan. So we would know then that tan 78 equals, what do we call this side? Well, the side is PT. So we want to use PT opposite over 5 adjacent. And now you see it's exactly the same kind of question that we've been doing. So pulling out the triangle and drawing it separately can be a nice way of working with these applied questions. So PT equals 5, multiply by 5 to clear the fraction. PT equals 5, 10, 78. PT equals, plug this into your calculator, and you get 23.523. Okay, so we're just going to write down a bit. We're not going to write down the whole thing. So we know also that PT equals PR. So we've got this piece of rope, and we've got this piece of rope. So we need this piece going around the arc. So that then is now a circle geometry question. Okay, so we know that the arc is going to equal a piece of the circumference. So some sort of fraction of 2 times pi times 5. What piece of the circumference? Well, if this is 78, this is also 78, which means this is 360 minus 78 times 2, which gives us 204. Okay, so the arc is a piece 204 over 360. So if you haven't already gotten comfortable with circle geometry, get there, or it's coming. Okay, that's just another piece that we need in this question. So when we calculate that, our arc equals 204 over 360 times 2 pi times 5. It equals 17.802. And again, we want those extra decimal places for our next calculations. So then we would have the rope length is going to equal PT plus PR. So 2 times 23.523 plus the arc, 17.802, which is going to give us 64.8 centimeters, because now we're going to round to 3 significant figures, and this was all in centimeters. So a question comes through, why do we not round higher up? Okay, why do we only round at the bottom? We always only round our final answer because each time you round a number, you lose some of the accuracy, you lose some of that detail. Okay? And then when you use that number again, your answer at the end can actually be wrong because it's not accurate enough. So while we're calculating, we always use unrounded figures, and then it's only at the very, very end of that final answer that we round to 3 significant figures. Okay, so next question. The line AB represents the glass walkway between the Petronas Towers in Kuala Lumpur. The walkway is 58.4 meters long and it's 170 meters above the ground. The angle of elevation of the point P from A is 78.3. Calculate the height of P above the ground. And you see again, when we look at this, we have a right angle triangle going on here. Okay? The height of P above the ground means we need this length, PB. We've got 2 sides in an angle, and we're working with a right angle. So again, we're working with SOHCAHTOA. Okay, what have we got? We have an opposite and we have an adjacent. So yet again, we are back with tan. So in this case, we're working in meters, not centimeters, and our final answer is not going to be PB, it's going to be PP plus 170. But what we're going to do is we're going to say then that height equals PB plus 170. Now we want tan. So tan 78.3 equals opposite PB over adjacent 58.4. So again, we multiply to clear that fraction. Multiply both sides, treat both sides exactly the same. PB equals 58.4 tan 78.3. Definitely things you want to be using a calculator for. So PB equals, when we type all of that in, we get 282.002. So again, I'm working to extra decimal places so that I keep that accuracy. So we've said that our height is PB plus 170. So then height equals 282.002 plus 170, which equals 452. 3 significant figures now, and our units in this case are meters. So P is 452 meters above the ground. So we've got a little bit more time. I'm going to keep going. Type quickly if you've got questions. This next one I put in to show you something a little bit sneaky. Okay? Because when you do a lot of the same type of question, sometimes you'll forget to think of other things. Okay, so in this diagram, O is a center, PQ is a tangent at P, OP is 5, and OQ is 12. Okay, now we've said tangents meet radii at right angles. So we think, oh, right angle, oh, SOHCAHTOA, and then we think, oh, hold on, problem. Remember, when we see right angle, we don't just think SOHCAHTOA. We think SOHCAHTOA and Pythagoras. If we are dealing with a case where we have 2 sides, no angle, now we have to work with Pythagoras. Because in this case, we're actually working with 3 sides only. We have 2 known sides, 1 unknown side. So this one here is a Pythagoras question. Here we have 12 squared hypotenuse equals 5 squared plus PQ squared. And then we can solve for PQ. But that is not the main aim of this lesson. I have only 2 minutes left to go, so you can solve for that one in your own time, and we are going to carry on with the last question, because this is the one type of question that really gives people headaches. This is a very applied question. It's still trig ratios, it's still SOHCAHTOA, but it's all about pulling out that triangle from a 3D shape rather than a 2D. So we have a pyramid on a square base. We have the diagonals of the base AC and BD intersecting at M. We have the sides are 8 centimeters and the vertical height is 5 centimeters. Calculate the length of the edge PB. So this one here. So the first thing I do in any question like this is I draw out my triangle. Who is the right angle triangle working with PB? It is this one, through M. So there he sits. Now we can see it a little bit more clearly. Okay, but we can also see we have the 5 from P to M, but we don't have MB. Okay, so if we want this length, PB, we're going to need some other information. We're going to either need a length here, or we're going to need an angle. We don't have any information about angles, so we're working with lengths. So in this case, we can see that MB is half of the whole diagonal, okay, right? So if we look at that whole diagonal, we have an 8, an 8, and an M, this is BD or it's AC. Okay, so we can do BD, it's fine. It's the same because it's a square-based pyramid. We have a right angle here, square-based pyramid, because now we're looking at the bottom of that pyramid, and look what we've got. Working with 3 sides, Pythagoras. So, MB equals 1/2 BD. And we know that BD squared is going to equal 8 squared plus 8 squared, Pythagoras. So BD is going to equal the square root of 8 squared plus 8 squared, 64 plus 64. So BD is going to equal 8 root 2, and MB is going to equal half of that, so 4 root 2. And I'm going to leave it like that, because again, it's like working with a fraction. I want to work with that exact value as I move forward in a sprint, because I see we're going to be running out of time very quickly. So MB is that. Now we know that this is 4 root 2. So it is very simply a case of doing Pythagoras again in order to get PB. So PB squared equals 5 squared plus 4 root 2 all squared. You're going to do a whole lot of working here, and you're going to get PB equals 7.55. Okay, to 3 significant figures, because they didn't tell us otherwise. The particular SOHCAHTOA bit now comes in part B. See how they now ask us to find an angle instead. Find the angle between PB and the base ABCD. So that is this angle here. And now you can see we've got sides, we've got angle, we've got right angle. So now we are working with SOHCAHTOA. So we've got these 2 sides which are exact. So we'll go with those. Who are they? Opposite and adjacent. So we know that tan x equals 5 over 4 root 2. So tan x equals 0.8838. And you see it's getting ugly. So we don't want to round that off in our calculator. We want to keep that in our calculator. Tan to the minus 1, 0.8838. So you can do 10 to the minus 1 and then you can press answer. So it pulls in that answer for your division and keeps it absolutely exact. And then x equals 41.5 degrees. Okay, angles in degrees to 1 decimal place. So our answer here would be 41.5 degrees. So the key thing when you're doing an applied question is be familiar with your SOHCAHTOA, but then make sure that you are always looking for that right angle triangle and then keeping in mind your Pythagoras and your SOHCAHTOA. I have gone a little bit over time, so thanks for sticking around. Have a wonderful rest of your Wednesday. I shall see you next week for your next installment.